In this module, we'll discuss different units of mass concentration and volumes that are typically discussed in environmental engineering. At environmental scales, we concern ourselves with the very small to the very large. Here you have a picture of a bacterium, Pseudomonas, which is typically about 1 micrometer in size. And then you have a picture of Tuttle Creek Reservoir, which has 750 billion gallons. Both of these are environmental systems that may be of interest. To give you an idea, a typical municipal wastewater treatment plant has 1 million gallons per day, which is expressed as 1 MGD per 10,000 people. So the Lawrence, Kansas wastewater treatment plant typically treats around 8 million gallons of wastewater per day for 80,000 people. The drinking water treatment plant usually produces 2 to 4 million gallons per day per 10,000 people. So chemical concentrations are often expressed as part per million or milligram per liter. This is because the density of water is 1 gram per milliliter. When you set 1 milligram per liter times the density of water, which is 1 liter per kilogram, you'll see that it's equal to 1 milligram per kilogram. There are 10 to the 6 milligrams per kilogram, and so you're left with 1 milligram and 1 million milligrams, or 1 part per million. So in a solution where the density of water can be assumed, 1 part per million can be interpreted as 1 milligram per liter. As our analytical instruments get better and we can measure at lower detection limits, we are now starting to look for concentrations in the ppb range, or part per billion, or in the part per trillion range, ppt. But many of the regulations we look at in this class will be at the ppm level, or part per million, or milligram per liter. Higher concentrations are typically reported as percent solution. I'm going to show you what 1 milligram per liter looks like in terms of percent solution to demonstrate this. You start with looking at 1 milligram per liter multiplied by the density of water. That equals 1 milligram per kilogram, which is equal to 1 milligram per 10 to the 6 milligram, which is equal to 1 times 10 to the negative 6. If you multiply this by 100, this can be expressed as a percentage. So 1 times 10 to the negative 4 percentage. That is extremely small. It can also be expressed as 1 part per million, as was demonstrated on the previous slide. Because the percentage expression is so small, when working at small concentrations, we usually discuss parts per million. But when working at large concentrations, you'll often see the percentage as the mass expression. So let's see what a 1% solution is equal to in the typical units you're used to. A 1% solution is equal to 1 per 100. We can say that this is 1 gram per 100 gram, or we could say it's 1 milligram per 100 milligram. For this demonstration, I'm going to say 1% equals 1 gram per 100 grams. I'm going to multiply this by the density of water, and this will get us to 1 per 100 gram per milliliter. Or, in terms of milligram per liter, there are 1,000 milligrams per gram and 1,000 milliliters per liter. So this could be expressed as 1 times 10 to the 4 milligram per liter. So a 1% solution is a very large concentration in terms of milligram per liter.